Vector! That's me, because I'm committing crimes in both direction and magnitude. I want it. But how should we do it?
You're both vectors, so we should find if your paths intersect. Now we should attempt to find an intersection point.
In order to find the intersection between vector and the moon, let RV represent vector's vector and RM represent the moon's vector. According to our calculations, this is the vector of the moon. Vector's vector spaceship can only move in 4 lines. There are 4 types of relationships these two vectors can have: intersection, coincidence, parallel, and skew. The lines may intersect at one point, be the same line, have the same direction and never intersect, or not have the same direction and never meet in 3D space. We have the vector of the moon and the first option for vector spaceship's vector. To find if they intersect, make each component, x, y, and z, of the two vectors equal. Then solve the simultaneous equations. Since they lead to a contradiction, we can see that these two vectors do not intersect. This can mean one of 2 things. They are parallel and not intersecting, or they are not parallel and not intersecting. We can test to see if 2 vectors are parallel by looking at their direction vectors. Parallel vectors are scalar multiples of each other. Since they are not in this case, these 2 vectors must be skewed. Now for the second option of vector's vector. First, taking the 2 direction vectors, we can see that they are factors of one another. However, they have different position vectors. The moon and spaceship move in the same direction, so they are parallel lines. As seen here, we reach contradictions when solving the simultaneous equations, demonstrating that they do not intersect. This is because they go in a straight line in the same direction, but at different starting points, so they never meet. Now for option 3. Since the 2 lines share the same position vector and direction vector, this means that they are coincident. They coincide in the same location, such that all the points on the 2 lines are the same. This scenario would only be possible if vector was already on the moon, and so they would be moving in the same line. Now for the last option. As before, make each of the components for the 2 vectors equal. Then solve t and s through simultaneous equations. Substitute t and s back into the vector equations, and we obtain the same point for both vectors, which gives their intersection point. Hence, this is the vector vector's spaceship should take to bring him from the Earth to the moon.